Okay, so this video won't be anywhere near as long as the last one. We're just going to start looking at random variables. In previous work on probability, we have often used words to describe events which can occur. For some events, we use numbers to describe the possible outcomes. A random variable uses numbers to describe the possible outcomes which could result from a random experiment. We often use capital letters such as X, which we've seen already, to represent random variables. Random variables can either be discrete or continuous. Now, in saying that, guys, we've already done everything on continuous. That was our chapter 8. And then also, obviously, moving on to chapter 9. So we've done that. So now what we're going to be looking at is looking at our discrete random variables. So a discrete random variable X has a set of distinct possible values. So for example, X could be the number of wickets a bowler takes in an innings of cricket. So X could take the values 0 up to 10. The number of defective light bulbs in a purchase order of 50. So X could take the values from 0 to 50. So it's something that can be counted, not measured. Like what we just discussed in the previous video about the difference between discrete and continuous numerical data. It's the same idea. Like what we're doing in chapter 9 was lots of things that could be measured, like the amount of Coke in a Coke can, the weight of lobster, all that sort of stuff, which was continuous. Now we're going to be looking at discrete. So I just realised that top sentence doesn't belong to this slide. But as a quick recap of continuous random variable X, a continuous random variable X can take any value within some interval on a number line. So for example, X could be the heights of men, which would lie in this interval, the volume of water in a rainwater tank, which could take this interval. To determine the value of a continuous random variable, we need to measure. And as I said, we've already looked at continuous random variables in chapter 8. So here, discrete random variables. In this chapter, we focus on discrete random variables. In this course, you consider only a finite number of outcomes, so we label them x1, x2, x3, up to xn. So here's another example for us. So a supermarket has 3 checkouts, A, B, and C. A government inspector checks the weighing scales for accuracy at each checkout. The random variable x is the number of accurate weighing scales at the supermarket. In part A, list the possible outcomes and the corresponding values of X. And part B, what values of X correspond to there being one accurate scale and at least one accurate scale. So I'm just going to move this up a little bit so we've got some room. So in part A, we probably want to think about the possible outcomes. There'd be lots of different ways you could do this. So possible outcomes. Okay, so we could set up like a table where we could have A, B, C, and X. So if we came along and so we were the government inspector and we measured A, B, and C and we found that all were weighing incorrectly, we could go cross, 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 meaning that X would be 0. Say we came along and the first one was okay, but the other 2 weren't, we'd have 1. We could then follow this pattern, 1, 1. Oh, that's definitely not across there, that should be a 1. We could have 2 working, couldn't we? So that would be 2, you could have 2 or 2, or we could have all working, and I think that's the only scenarios there. We'd have 0, 1, 1, 1, 2, 2, 2, and 3. So that's all the different possible outcomes you could have. Now if we look at part B, B is saying what values of X correspond to there being one accurate scale. And it's as simple as this. What values of X correspond to there being one accurate scale? Well, obviously in this case, X is going to be 1 if there's one accurate scale, which obviously can occur in 3 different times, but all we're looking for is X is equal to 1. If we're looking at part 2, at least one accurate scale, so we can't have 0, because that would be no accurate scales. We're going to have that X could be equal to 1, 2, or 3, because that would be at least one accurate scale. And I told you this video would be heaps shorter. So the other questions I need you guys to do on Wednesday next week is from exercise 7A, question 1, 2, 3, 5, and 6. But as I said, there will be time in class to do both the questions from chapter 6 and from this chapter 7.